everyone, I am Janapolis Mamagulo, currently studying at the Panong College of Agriculture, Sciences and Technology, taking a Bachelor of Secondary Education major in Mathematics. Video I will discuss about the different rules of derivatives, the constant rule, power rule, product rule, quotient rule, and chain rule. Introduce you first the derivative notations. The most commonly used are the Lagrange notations. We read this as f prime, and the Leibniz notation, the derivative with respect to x. We will now start the constant rule. The constant rule tells us the derivative of a, where a is constant, is always equal to 0. The derivative of 2 must be equal to 0 because 2 is constant. It cannot be changed its value. It is a fixed number. So it must be equal to 0. The derivative of 3, the derivative of 1/2 must be equal to 0. So that is the constant rule. We will now proceed to the power rule. The power rule tells us that we have some function of f of x is equal to x to the n power, where n is not equal to 0, so n can be a positive or a negative number. The derivative of this, we have f prime of x is equal to, so the exponent n become the coefficient of x raised to, so the exponent subtract n by 1, so that would be the exponent. So we have n times x raised to n minus 1. For example, if we have f of x is equal to x to the third power, so we need to apply the power rule. F prime of x is equal to 3, which is the exponent, become the coefficient of x, subtract 3 by 1, so 3 minus 1. So we have 3 times x squared, so 3 minus 1 is equal to 2. So the derivative of x to the third power is equal to 3x squared. So we will now apply those rules in taking the derivative of such polynomial expression. If we have g of x is equal to x to the third power plus 3x squared minus 4. What we're going to do is to derive both sides. So we have the derivative of g of x is equal to the derivative of x to the third power plus 3x squared minus 4. So next, we need to derive each term. So we have the derivative of x to the third power plus the derivative of 3x squared minus the derivative of 4. And we need to simplify. So the derivative of x to the third power, so 3 become the coefficient of x, so 3 minus 1 is equal to 2. So we have 3x squared plus the derivative of 3x squared. So we need to take 3 times the exponent 2. So 2 minus 1 is equal to just 1 or x. So we have 3 times 2x. Derivative of 4 is always equal to 0. That is the constant rule. So we need to simplify this one. So we have 3x squared plus 6. 3 times 2 is equal to 6x. So the derivative of x to the third power plus 3x squared minus 4 is equal to 3x squared plus 6x. So we will now talk about the product rule. If we have some function that can be expressed of the product of two functions, so let's say we have f of x times g of x, and we need to get its derivatives. That is going to be equal to f prime of x times g of x plus f of x times g prime of x. So that would be the product rule. The derivative of the first function, this one, times the second function plus the first function times the derivative of the second function. For example, if we have g of x is equal to x times cosine of x, so we need to apply the product rule. So our f of x here is x, and the g of x is this cosine of x. So the product rule tells us the derivative of the first function, which is x, so we have derivative of x, times the second function, which is cosine of x, plus the first function, which is x, times the derivative of the cosine of x is negative sine of x. So what would be the derivative of x? So we will now apply the power rule. X is the same as x to the 1 power. So the derivative of x to the 1 power is equal to the exponent 1 and 1 minus 1 is equal to 0. So we have 1x raised to 0. And any number or variable raised to 0 is equal to 1. So we have 1 times 1 is equal to 1. So derivative of x is equal to 1. It's just 1 times the cosine of x. So cosine of negative sine of x times the positive x is going to be equal to negative x times sine of x. So derivative of x cosine of x is going to be equal to cosine of x minus x times sine of x. So we will now proceed to the quotient rule. The quotient rule tells us that we have some function of f of x that can be expressed as the quotient of two functions. Let's say we have u of x over v of x. So our f prime of x is equal to the derivative of the numerator, which is u prime of x times the denominator, not derivative of the denominator, v of x, minus the numerator, not the derivative, u of times the derivative of the denominator, which is v prime of x, all over the squared of the denominator, which is v of x squared. For example, if we have f of x is equal to 4x squared over sine of x, so we will now apply the quotient rule. F prime of x is equal to the derivative of the numerator, which is 4x squared, times denominator sine of x, minus the numerator 4x squared times the derivative of the denominator, which is sine of x. All of that over the square root of denominator, sine x raised to 2. And now we will apply the power rule of this part. The derivative of 4x squared, so 4 times the exponent, 2. 2 minus 1 is equal to 1, so 4 times 2x times sine of x minus 4x squared, and the derivative of sine of x is equal to cosine of x. All of that over sine of x raised to 2 is just equal to sine squared x. So we just simplify this one. So 4 times is equal to 8x times sine of x minus 4x squared times cosine of x. All of that over sine squared x. So that would be the derivative of 4x squared over sine of x. Last, we will now talk about the chain rule, a core principle in calculus which is a little bit difficult. So if we have some function of h of x is equal to the quantity of f of g of x, our h prime of x, or the derivative, is going to be equal to f prime of g of x times the g prime of x, or the derivative of the outer function times the derivative of the inner function, which is the g of x. For example, if we have h of x is equal to the quantity of 2x squared minus 1 raised to 6. So what we're going to do is to find what would be the outer function and the inner function, or the f of g of x and the g of x, which is the outer function. So in this part, the outer function would be the 2x squared minus 1 raised to 6. And the inner function is 2x squared minus 1. So that would be the inner function. So the h prime of x is going to be equal to the derivative of the outer function, which is 2x squared minus 1 raised to 6, times the derivative of the inner function, that is only 2x squared minus 1. This is the inner function. And we need to apply the power rule. Our exponent is 6, so that would be the coefficient of this 2x squared minus 1. So 6 minus 1 is equal to 5. Times the derivative of 2x squared minus 1, so we will just apply the power rule and the constant rule. The derivative of 2x squared minus 1, so derivative of 2x squared, so 2 times the exponent 2, then 2 minus 1 is equal to 1, so 2 times 2x raised to 2 minus 1. Derivative of 1 is equal to just 0. So we'll just simplify this part. So 6 times 2 times is equal to 4, so 6 times 4 is equal to 24, x times 2x squared minus 1 raised to 5. So that will be the derivative of 2x squared minus 1 raised to 6.